Hey everybody, my name is Emmanuel Jakob, and I want to cover a little bit in this video some of the advanced forecasting methods that are covered in our enterprise forecasting class at Liberty University. So to get started, let's talk a little bit about dynamic regression models. So dynamic regression models are basically, well, first of all, regression models in general are good at predictions. They normally see their multiple regression or linear regression models, which we'll see in kind of the elementary phases. However, when it comes to data that either has multiple time series or financial data that's it's got a lot of trends, cyclical components, regular components, they're really better suited for dynamic regression models. So that's dynamic regression models. Secondly is a VAR, or a vector autoregression. It's also used for multivariate time series. The difference with VAR is each variable is a linear function of a past lag of itself, which is why it's an autoregression itself, and the past lags of other variables as well. Generally speaking, you see VAR as VAR in parentheses P, where P denotes the number of past lags. So you'll see VAR2, which is a vector autoregression with 2 lags. Next is a neural network model. Neural network really kind of acquires its data through learning, and basically is why it's called a neural network, because it's based off of a mathematical model, or a simple mathematical model, the brain. And it allows for really complex nonlinear relationships between response variables and its predictors. And last one we're going to talk about, one of the advanced models, is a hierarchical or group time series. Basically what happens with these types of things, you end up disaggregating a time series of data. For example, you look at you can look at Honda sales across the United States for the past decade. And when you take that data over for all Honda sales, now you want to disaggregate that data and say, well, how many Pilots, how many Civics, how many CRVs did we sell, and then how many CRVs that were red, or how many Honda Accords that were, tan with, manual transmissions. So by disaggregating a time series, you're able to kind of break down the data and get it into more of a hierarchical. And the reason being because it ends up looking like a tree diagram. So next up, I want to kind of show you an example of how to forecast a neural network. And we're going to use some credit data, and we're going to use R for this data. So hold on tight. Now this is R. I've already run this in R, so I'm just going to run it through one more time with you around. So this is data that we've actually used from a website called otex.com. It's a really great website. It's actually got a forecasting or advanced forecasting book, and we're using the data in there in R as well. So first thing you want to do, we want to load the libraries. Load library FMA, FPP, and caret. So we're going to go ahead and let that load. And once it has, next thing we're going to do is load our data. So you can see our data, we're going to call it credit log, and the data frame is from our credit score. We're going to call that score equals credit score. We're going to take a log of the savings, add 1 to make sure it's positive, log of the income, add 1 to make sure it's positive. So in other words, that's the credit data in the income column, plus 1. Log of the address, again, we're calling that log address is equal to log of credit data in the time address, plus 1 again to keep it positive. Same thing with employed, and credit FTE and credit single. So this is all basically the data frame. We can run this, and then next, after we've run the data frame, we want to run a neural network on it. So we do a neural network by credit fit. In other words, this is us fitting the neural network on that data that we already have now. So we're looking at the score again, the savings, income, address, employed, and so on and so forth. Alright, so this is basically after 100 iterations it stopped. It ran a fit on that neural network. So the next thing we want to run is now we're going to run some data through it. So this is basically the sets of data that we run. I'll tell you exactly what they are afterwards. So we're now storing this into MyDF, and what that means is, so now what we're doing is we're adding names to the MyDF, which we ran in here. So this is our savings index. Obviously we're logging these, so it actually doesn't look like a savings account number. Income, address, employed, FTE true, and single true. There we go. So now with that information, we can predict MyDF, comma, credit fit, comma, MyDF. And again, based on what we've put into these parameters here, we're now basically predicting what the score would be. So there we go. That's how to use a neural network to forecast a credit score data using RStudio. Thanks for watching.